Consider the region R, which is containing all the ordered pairs x, y, which satisfy these two conditions. Let F be the family of circles that are contained in R and have centers on the x-axis. Let C be the circle that has largest radius among the circles in F. Let alpha beta be a point where the circle C meets the curve y square equal to 4 minus x. The radius of circle is dash. And second question is the value of alpha is dash. Before I do this question, I will tell you a very important concept of circles, that is the concept of point circle. And the concept of point circle says that suppose some line say 2x minus 3y plus 5 equals 0 and minus 1 comma 1 is a point on the line, and we have to find a circle touching this line at the point minus 1 1, and some third condition is given and you have to find the equation of circle. Whenever some circle touches some line at some point, we always use the concept of point circle, and the concept says that suppose there is a very small circle of radius 0 placed here. The equation of that circle will be x minus minus 1, that is x plus 1 whole square plus y minus 1 whole square equals 0. And we can say that our circle is passing through the intersection of this point circle and this line. Therefore, the equation of our circle will become x plus 1 whole square plus y minus 1 whole square plus lambda into the line, that is 2x minus 3y plus 5 equal 0, and the value of lambda we can get with the help of third condition given in the question. Whatever is the third condition given in the question. And according to question, let F be the family of all circles that are contained in R and have centers on x-axis. First, let me tell you the geometrical meaning of R. It is clear from the equation of parabola that the parabola will be leftward parabola, and that parabola will have vertex 4 0, and because it is given that y square is less than equal to 4 minus x, this property will be satisfied by all the points lying inside this parabola, and because x is greater than equal to 0, these are all those points which are lying in the region R. And then he says F is the family of all the circles which are contained in R and have centers on x-axis. That is, F is representing all the circles which have centers on x-axis and lie completely inside this shaded region. For example, this. In this way you can draw infinite number of circles. For example, one more is this. And now we have to find the circle which is lying inside this shaded region and is of largest radius. It is clear that the circle having largest radius lying inside this shaded region will touch y-axis at the point origin. That is, I can say circle will be of the type this. That is, it will be touching parabola at two different points and touching y-axis also. But you may say that what is the guarantee that the circle is touching parabola at two different points? Maybe that the circle is touching parabola at this point. Actually, what is the situation? after calculation we'll get it. First thing is using the concept of point circle. As I told you, equation of the circle x minus 0 whole square plus y minus 0 whole square plus lambda into x equal 0, because the equation of y axis is x equal 0 and the point where the circle is touching y axis is the point origin, and the concept of point circle I have just now told you. Therefore, using that concept, equation of any circle of the family touching y-axis at origin will be of this form. And because I want that the circle should lie inside the parabola, it means when the circle will be of largest radius, at that time this circle and the parabola will touch each other. This can be written as x square plus y square plus lambda x equal 0. And because the circle and the parabola are touching each other, and we know that the equation of parabola is y square equal to 4 minus x. Hence, because these two curves are touching each other, if I eliminate y, I'll get a quadratic equation in x. And that quadratic equation in x should have both the roots equal for the two curves to be touching each other. You must be knowing this concept of touching of two curves. I put this value of y square equal to 4 minus x in this circle. I get x square plus 4 minus x plus lambda x equal 0. And this means x square plus lambda minus 1 into x plus 4 equal 0. And because both the roots of this equation must be equal, therefore d will be equal 0. That is lambda minus 1 whole square minus 16 equal 0. That is lambda minus 1 is equal to plus minus 4. That is lambda equal to 5 and minus 3. It is clear that the center of this circle has coordinate minus lambda by 2, and because I am dealing with those circles which are lying on right hand side of y-axis, that is minus lambda by 2 should be positive. Therefore, out of the two values of lambda, I'll be choosing that value of lambda for which minus lambda by 2 is positive. Hence, I get the value of lambda as minus 3. 5 will be rejected. Hence, for lambda equal to minus 3, I will get the circle x square plus y square minus 3x equal to 0. And now, after putting lambda equal to minus 3, the value of x I will be getting will give us the coordinate of point of contact. If lambda is minus 3, I get x square minus 4x plus 4 equal 0. That is x equal to 2. That is, I can say the point of contact have coordinates 2, 2, and y coordinate we can find very easily by putting x equal to the value of y I get are root 2 and minus root 2. But we require the value of alpha only, hence alpha will be 2, and the radius of circles also required. It's clear that the radius of this circle is 3 by 2. Hence the answer to question number 7 is 3 by 2, and answer to question number 8 is 2, because the point of contact was having x coordinate 2.